Hi guys, and welcome to the next video in the Chemical Earth topic. This one's going to look at separating substances and some of the different methods of separation that we have. Hopefully most of these you'll be familiar with, and we just want to match them with the most appropriate mixtures. So firstly, separating methods. We're going to look at a range of different mixtures and try and understand why there are different methods chosen in order to separate their components. Most of the separation methods we're looking at will be physical methods, primarily because we're looking at the physical properties or the differences in the physical properties of the components of the mixtures in order to make decisions about which methods we will choose. Because the components of different mixtures exist in different states, solid, liquid or gas, and also because even within the same state, the properties of those substances can be different in terms of their physical properties. That's why we need to choose different methods for different mixtures. So we need to have a little bit of a look at the nature of the particles, as I said, the state, and some of their physical properties in order to determine which methods we're going to use. We're going to have a look at a few of these. First method we want to look at is separating solids. When we have solids of different sizes, then the method that we choose is sieving, or I guess a form of filter which has large and small sized holes. Using different meshes of different sized holes allows certain sized particles to pass through and others to remain in or trapped on the mesh. If one of the solids is ferromagnetic, such as iron, then we may use a magnetic separation method. But most of the time, if we just have a mixture of different sized particles, solid particles, then some sort of a mesh or sieve is sufficient to separate them. When we have mixtures involving solids and liquids, the solids can be in one of two forms. They can either be dissolved solids or they can be undissolved solids and therefore form suspensions. If the solids do not dissolve in the liquid, then we use the process of filtration. Filtration is I guess, an alternative to, if you think about it, to sieving. Sieving just involves having some sort of a mesh with holes of a certain size that some particles can pass through and others cannot. Filtration is really the same thing. Water molecules and dissolved solids pass through the filter, but larger undissolved solids remain as a residue in the filter paper. So any of our liquids, usually this will involve water as our liquid, and if there are any dissolved solids, will pass through the filter, but any insoluble solids, any solids that do not dissolve, such as precipitates, will remain in the filter paper. So of course, this is going to involve the use of a filter funnel and usually filter paper, and the residue will be what is collecting in the filter paper at the top, and then the filtrate is what is collecting, in this case, in the conical flask down below. Of course, I've drawn this very quickly freehand, so make sure you're using a ruler when you're drawing your diagrams. If the solids are dissolved in the solution, then filtration won't work, and that's when we need to move up to evaporation. Evaporation allows the liquid to be completely removed by boiling. This is based on a difference in the boiling point between the solid and the liquid. So if the dissolved solid has a higher boiling point, then the water will boil and be removed and it will leave the solid behind. We can use this method to separate the salt from seawater. When we have two liquids together, there are two methods that we tend to use. Miscible means that they will make a solution. They will mix. So one will dissolve in the other. Immiscible means they will not mix. And for immiscible mixtures of liquids, we just can use a separating funnel, provided, of course, that the two liquids have a different density. So this is based on density. That is, one liquid sitting above the other. So if we put them in a separating funnel, then we can draw off the denser liquid from the bottom and leave the less dense liquid remaining behind in the separating funnel. But if the two liquids do mix together, if they are soluble one in another, then we can't use a separating funnel. So we need to use another method, and in this case, we choose distillation. Unlike evaporation, where the liquid just disappears and we don't collect it, distillation allows us to collect both components of the mixture. Distillation works on the basis of differences in boiling points. And the difference in boiling points needs to be reasonably significant. If there's only a 5 to 10 degree difference, it's very hard to control the boiling sufficiently to make sure that we're getting a level of purity. You'll know when you boil water that the boiling process of liquid turning into a gas doesn't all happen at exactly 100 degrees. Some of the bubbles start well before the temperature of the water has reached 100 degrees. So that's one of the reasons why when we're using distillation, we have to make sure that we have a very controlled process. As we control the temperature, the liquid with the lower boiling point will start to reach that and start the phase change from liquid to gas. As they rise up out of the vessel, we condense that gas back to a liquid and we allow it to drip off into another container. That way we can separate the two liquids. Of course, when you're using this method, you need to make sure that you control your temperature so you don't just end up transferring the mixture from one vessel to another. And then we can have mixtures of gases, such as we do in air. If we're going to separate the components of a gas mixture, then one of the methods we can use is gas chromatography. The method of chromatography is based on particle size, and you may have used this method in the junior years, perhaps to separate the different color pigments from a texture or even from a leaf. What we do with our chromatography is we allow the particles to, generally speaking, be dissolved in some sort of a medium that is going to allow them to move through that medium. We do that by passing an electric current through the medium, and then the lighter molecules tend to be able to travel further than the heavier molecules. They have a greater inertia, and so they don't tend to move as quickly. So we see in our chromatography a series of bands corresponding to, for example, the different colors in a texture, the different colored pigments in a leaf, or the different gases in a mixture of different gases. So here's a 4-mark question. I'd like you to justify your choice of physical separation method to obtain a pure sample of R from a mixture of the substances listed below. This sort of information is what's often given to you in questions, and in order to do these sorts of questions efficiently, you need to understand the verb. Justify means give reasons for your response. So we need to pick a method and then suggest reasons why we've picked that method. Well, we have a lot of features of the 3 different materials here. We've got their state at 25 degrees. We've got their solubility in Q. We've got their solubility in water, their melting point, and their density. We can see some differences in density, and if they were all liquids, and they were immiscible, then that may work as a reasonable separation method. 2 of these have very high melting points. And so that too is not a particularly good one. But the solubility of both P and Q is high in water, whereas R is insoluble. So if we were to make a solution by adding water to this mixture, P and Q would dissolve, but R would not. R is insoluble. Okay, so solution with water. So then, if P and Q remain in the water and R is insoluble, then we can use the separation method of filtration to separate this mixture. So my choice of physical separation method would be filtration. My justification is that if we make a solution with water, P and Q will dissolve, R will not dissolve, and therefore it can be separated out as a residue when we use the method of filtration. How did you go?